In this video, we are going to sketch the graph of this function, of trigonometric function given here. We are going to make a table of values for the 5 key points over one period, and then sketch it over 2 periods. The first thing to do is change of variable. So we're going to call phi all the expression that is inside the sine function for x plus pi over 16. This is x. So all this expression here, it's going to be called phi. Now when we do this, our function becomes much simpler. 0.5 sine phi plus 2.5. Good. We are going to deal with this now. Find the values of the sine phi. So let phi take values from 0 to 2 pi on the unit circle on the right. So the unit circle here, phi equal to 0. Phi equal pi over 2. This is an angle in standard position. Then pi, then 3 pi over 2, and then 2 pi. Remember, on a unit circle, any point on the unit circle has the coordinates cosine theta, sine theta, theta being the angle in standard position. So if we look at this point, which has coordinate 1, 0, this is the cosine of 0, this is the sine of 0. Now this is pi over 2, yeah? This is pi over 2 here. Now if we look at this point has 0, 1. So this is the cosine of pi over 2, this is the sine of pi over 2. Now if we go to this point, it's negative 1, 0. And this is the cosine of pi, this is the sine of pi. Now this point here, it's 0, negative 1. Again, it's the cosine and the sine of 3 pi over 2. And then we come back to 2 pi, and it's again 1, 0. So we know the sine of phi, and this goes from 0 to 2 pi. Now let's look at the following table. In this table, what we have phi going from 0 to 2 pi, which means 1 period. Sine phi, it's all here in the unit circle. You don't need to memorize anything. So sine of 0, we go here to 0. Sine 0 is the y of this point, the y coordinate, which is 0. Sine pi over 2, it's 1. It's the y coordinate of this point, y equal to 1. Then 0. Then negative 1, then 0. If you want to memorize these values, that's fine. But you don't have to. The unit circle gives you everything. We now go and find y. Y is equal to what? Negative 0.5 sine phi plus 2.5. So sine phi equal to 0. Put 0 here. That gives you 0, 2.5. 2.5. When phi equal pi over 2, sine phi equal to 1, put 1 here. Negative 0.5 times 1 plus 2.5, that will give you 2. Sine phi equal to 0, put 0 here. That all this 0, 2.5. Sine phi equal negative 1, put negative 1 here, plus 0.5, 3. And then the last one, 2.5. Now, we now use the values in the table, which gives us y values for over one period of x. Now, it's one period of x because phi was over one period. And the relationship between the two is linear. So one period of phi gives you one period of x, which extend from negative pi over 16 to 7 pi over 16. So let's find the period. The period is this point, 7 pi over 16 minus is the distance, remember. So 7 pi over 16 minus pi over 16, that gives me 8 pi over 16. Another way, another method of finding the period, you say pi equal to 2 pi. It's a formula. It's 2 pi divided by b. B is this coefficient here. So if you divide 2 pi by b, b equal to 4, that gives you pi over 2, which is equal to 8 pi over 16. So now we just put the values. Now negative pi over 16, y equal 2.5. So negative pi over 16, y is negative is 2.5 somewhere here. Plus pi over 16 gives me 2. 2 plus pi over 16 gives me 2. So 2.5, 2. And then 3 pi over 16, 3 pi over 16, 2.5 again here. 5 pi over 16 gives me 3, so 3 it's up at the top here. 7 pi over 16 gives me 2.5 on this is the line 2.5, yeah. So it goes like this, and then we can now join the point slowly to have a sine wave of one period extending from minus pi over 16 to 7 pi over 16. Now the graph is to be extended to the second period. We need to add one period here, so 7 pi over 16 plus one period. We found the period here, 8 pi over 16. We take this one because it has the same denominator, so place 8 pi over 16. That will give me 15 pi over 16. So 7 pi over 16, and here 9 pi over 16, and here 11 pi over 16, and here 13 pi over 16, and here 15 pi over 16, the end of the second period. And then we just reproduce the values, so this will be this point, same as this point. This will be here, 13 pi will be here, and 15 pi will be here, and we just join this point slowly, slowly, slowly. And here we have the second period. Now let's do it again. So slowly here, slowly, and then the point here. So one period, and the second period is here. We can go and label the points. For example, this minimum here is what? 7 pi over 16 and 2. X equals pi over 16. For this point, x equals pi over 16. The value of y is 2. We can label the maximum. The maximum here, it's what? The x is 5 pi over 16. And the y is 3. And we can label the other points as well. So this is one way to sketch sine functions. Although they are complicated, I assume that with this method of substitution, it makes it a lot easier, either in calculation or in sketching without memorizing any of those formulas.